Hello learners, welcome you all in this session. In today's session, I am going to discuss about the electricity sector in India. We will discuss the overview of this, and this is mainly the part of the power distribution sector. The course we are conducting in IGNOU, this is a part of the Advanced Certificate in Power Distribution Management. Learners, I am Dr. Rakhi Sharma from School of Engineering and Technology, Indira Gandhi National Open University. So friends, electrical power is essential for economic development and for improving the quality of life. So this electric power is the key input to any economic activity in industry, agriculture, trade, commerce or the service sector. There has been the tremendous improvement and augmentation in the capacity addition and transmission and distribution network since our independence. So we have significant generation capacity in our country, but still all of us do face some power cuts or no power supply. So here we shall attempt to find answers to some questions in this module of the session. Basically this is comprising the 3 sessions. A rapidly developing economy like ours in India faces an ever increasing demand for electrical power. So what measures are needed to cater this demand for electricity? What are the key issues and challenges that need to be addressed to provide reliable and good quality power supply? Again question comes, what steps can be taken to meet the challenges before the power sector? So it is our belief that armed with an understanding of these issues, you will be better prepared to handle the problems in power sector. So learners, we begin by constructing an overall pictures of electricity sector in India so that you do not look at the power distribution sector in isolation, but acquire a wider perspective. And electricity sectors or this electrical power supply system has 3 main components. What are these? These are power generating station, transmission lines and distribution lines. So you can see this figure. This is a typical electrical power supply system. You can see here how the power is transferring from the generating station to the end consumers. So this supply system has generating units that produce electricity. Then it has high voltage transmission lines that transport electricity over the long distances. So you know that power is transferred over the long distances with the very high voltages. Again, low voltage distribution lines are here that deliver electricity to consumer. Then typical supply system, this has the substations which are the part of the electrically transmission and distribution system where the voltages are transformed to lower levels for distributing power to the end users. So power is distributed at the low voltages. So these substations have transformers, step down transformers. Then energy control centers to coordinate the operation of the various components. So learners, we shall discuss about generation and transmission of electricity very briefly in Indian context and then focus on the power distribution sector. So do you know what the total electricity generation capacity of the power utilities it was in 1947? It was meager 1362 megawatt. You can assume that you can see that this is how low is this. Now it has increased to about 370 gigawatt or 3,70,048 megawatt as on 1st March 2020, which is about 272 times in about 70 years. You can see the figure where you can see the growth. Another 54,932 megawatt of captive generating capacity is supplying power to the consumers. The independent and individuals or industries, they are producing their own power for their plants. So This is the captive generating capacity. And further, there has been a significant increase in power generation capacity in last 70 years. You know that our country has overcome the power shortage to a large extent. As per the official statistics, the total energy shortage during the year 2019-20 stood at 0.4%, and a peak shortage was 0.4% during the same period. So, let us look at the power generation sector very briefly to understand the options available to us. Electrical power generation in India relies on 4 basic energy sources. What are these? These are fossil fuels such as coal, oil, natural gas, hydroelectricity, then nuclear power, then renewable energy sources. What are these renewable energy sources? These are also called the non-conventional energy sources or clean energy sources such as biofuels, solar, biomass, wind, tidal. As of March 2020, about 62% of the power generation capacity in India is from coal, gas and diesel thermal power plants. Hydroelectric power plants account for about 12% of total electricity generation capacity. Nuclear power plants for about 2%, and remaining 20% generation capacity comes from renewable energy sources. So, this is the general electric power mix in India in March 2020. So, what are the future directions in this electricity sector? So, the government of India has envisaged installed capacity of 4,76,431 megawatt, or we can say about 476 gigawatt by 2022 to meet the power requirements. The large coal reserves in our country provide a ready and economical resources and ensure energy security as of now. Hence, coal has been identified as the mainstay fuel for power generation. India is aiming to have 40% of the total installed capacity by the year 2030 based on fossil fuels, non-fossil fuel sources. Non-fossil fuel sources means renewable energy sources as submitted in intended nationally determined contributions. So, the overall target for renewable energy generation capacity is 1,75,000 megawatt by 2022. This is 175 gigawatt you can say. So, of this how much we have realized so far? So, 87 gigawatt or 87,000 megawatt has been realized so far. Electricity Act 2003 about which you will study in our next session. In this act, it mandates all state electricity regulatory commission, that is SERC, for fixing a minimum percentage of energy consumption in a distribution licensee's area for procurement from the renewable energy. So, the entry of renewable energy can help us in energy security and meeting our energy requirements. Another step in this direction is the scheme of allowing captive power generation, which refers to generation from a unit set up by an individual, cooperative society or industry for their own consumption. So, friends, industries in the manufacturing sector like cement, aluminium, fertilizer, steel, paper, sugar, etc. have their own captive power plants to supplement the electricity purchased from the power utilities or for producing energy. So, this has implications for the utilities, as you will learn further. Do you know energy ranks 6th in the world? India ranks 6th in the world in terms of electricity generation after United States, China, Japan, Russia and Canada. However, the annual per capita consumption in India at about 1181 kilowatt hour per year. It was calculated in 2018-19 and this is amongst the lowest in the world. So, China's installed capacity rose from 1850 megawatt, which was in 1915. This has raised to the 20 lakhs 10,000 megawatt in 2019. So, the T&D losses in the China are only 5.9% as compared to 21% in India, and almost 100% population in China has access to electricity, or we can say the annual per capita consumption in China is, this is 5,177 kilowatt hour as compared to the India's 1,181 kilowatt hour. So, you can compare what is the rank of India and what we have to do in this direction. So, now let us discuss about the transmission and distribution. In India, the power plant typically produce 50 cycle per second, or which is cycle per second means hertz, alternating current with voltage between the 11 kilovolt and 33 kilovolt. The generation is done at the 11 kilovolt and 33 kilovolt. Here this is a typical voltage. Then electric power is brought from the power plant to the consumer through an extensive transmission and distribution system comprising distribution network, state grids and regional grids. So, at the power plant site, 3-phase voltage is generated and step up to the higher voltage for transmission on line strung on cross country towers. So, we are discussing the various stages of the transmission and distribution process. So, that means we are saying that the first at generating plant the power is produced at 11 kV, then this 3-phase voltage is generated and this is a step up at higher voltage for the transmission. Then high voltage and extra high voltage transmission, which is called HV and EHV transmission, is the next stage to transport the AC power from power plant over the long distances at voltages like 220 kilovolt, 400 kilovolt, 765 kilovolt. In special cases, high voltage direct current transmission, which is called the HVDC, is preferred, like 500 kilovolt and 800 kilovolt. So, various stages of the transmission and distribution process. Then among this you will also see the sub transmission network. Sub transmission network means which will be the voltage somewhat less than the high transmission network. So, this is at the 132 kilovolt, 110 kilovolt, 66 kilovolt, 33 kilovolt, 22 kilovolt constitutes this next link towards the end user. That means we are step down the voltage. Then comes to distribution. Distribution at 11 kV, 6.6 kV, 3.3 kV. This constitutes the last link to the consumer, who is connected directly or through step down transformers. So, these step down transformers bring the voltage levels down to 400 volt for 3-phase 4-wire secondary distribution. The single phase residential lighting load is connected between any phase and neutral. That means it is 230 volt, 230 volt which we get in our residence. So, this is the single phase voltage, and the 3-phase load is connected across the 3-phase lines directly. The transmission and distribution network includes substations, lines and distribution transformers. Substation containing step down transformers reduce the voltage for distribution to industrial, commercial and residential customers. So, these substation and distribution lines are referred to as distribution system. Transmission lines are usually capable of transmitting large quantities of electric supply or electric energy over the long distances. They operate at very high voltages. Distribution lines carry limited quantity of the power over the shorter distances. The state distribution utilities or state governments through the state electricity department primarily own and operate the distribution network and state grids. For this, the state distribution utilities are responsible. The Power Grid Corporation of India Limited, which is called the PGCIL, This owns and operates most of the inter-regional transmission lines. These inter-regional transmission lines forming a part of the national grid. Basically, these owns and operate most of the inter-regional transmission lines in order to facilitate a transfer of surplus power to the deficit region. In some regions, the power is surplus, in some region the power is deficit. So, these grid, the national grid, this work for that to transfer the power from surplus region to the deficit region. The entire country has currently been divided into the 5 regions or zones for the transmission system. What are these? These are the northern region, northern eastern region, then southern region, then western region. So, the interconnected transmission system within each region is also called the regional grid. When it comes to the region, that it is called the regional grid. Each region or zone has its regional load dispatch center. So, a national power grid inter-regional transmission capacity has also grown significantly over the years and stood at 102 gigawatt as of March 2020. So, a perspective transmission plan has been evolved for strengthening the regional grids with the objective to establish a strong and vibrant national grid to support the envisaged generating capacity addition of 176 gigawatt during 2017 to 2022. This move is expected to help in optimal development and utilization of coal, hydro and renewable energy resources. It is also aimed at improving the economy, reliability and the quality of the power supply. For example, the energy resources in our country are unevenly distributed. The coal resources are abundant in the Bihar, Jharkhand, Odisha and West Bengal. Hydro resources mainly concentrated in the northern and the northern eastern regions. So, that is some regions do not have adequate natural resources for setting power plants to meet their future requirements, whereas other have abundant natural resources. So, the national power grid as an integrated entity can serve as an effective tool to accommodate energy of different regions and transfer electricity from power surplus region to power deficit regions. A major portion of distribution network is controlled by the restructured power distribution companies, which were earlier state electricity board, and a very small section by private power utilities. So, as a part of this system, you are responsible for its efficient working. You will agree that a well managed power distribution network holds the key to consumer satisfaction, a healthy economy and national prosperity. We have so far presented a broad picture of the electricity sector in India. So, it is unfortunate that in spite of having abundant energy resources and large pool of highly skilled human capital, we are faced with many problems in 3 components of the power supply system: in generation, in transmission and distribution. We list some of these in this table and you may like to add some more in this list. So, various problems in the generation, transmission and distribution segments of the power sector. In generation segment, lack of optimum utilization of existing capacity, generating capacity. So, in some places you will find the capacity is not being utilized optimally. So, this is the problem. The plant can generate more power, but it is not being utilized properly. In the transmission, lack of grid discipline is there when they are interconnected, inter-regional grids are there. So, each state should play its own part. So, maybe in some places there is a lack of grid discipline, and because of that the problem may come. In the distribution side, some problem may come, like, and we can say the major problems is in the distribution side. Inadequate and aging sub-transmission and distribution network leading to frequent power cuts and local failures, the faults at some places. So, erratic voltage and the power quality. So, these are some problems in the distribution sector. So, some other problems in distribution sector are large scale theft, skewed tariff structure. Tariff structure is not uniform for all the places. So, then insufficient or inefficient use of electricity by the end consumer. It can also be there that the power supply is there, but it is but demand is not high. So, the electricity is not being utilized at particular place. Then again some problem with the transmission is that the transmission losses, these losses should be low, but in our case the transmission losses are 6 to 8%. So, these should be minimized. Then the other problems with the distribution sector is that distribution losses, which is the major problem in the key issue area in the power distribution sector. So, in some places we have found that these losses are up to 40%. We have seen the case of the India and China. So, we have reduced the distribution losses up to much extent, but still it needs our attention that it should be reduced further. Day to day problems of the consumers, like hurdles in getting the new connections or enhancement of loads, the stiff procedures, unfriendly commercial policies. This is also the problem of the distribution sector. Then tardy metering, faulty metering, inflated billing because of that, and insufficient collection avenues at some places, and hostile staff can be also there. Then this is also one of the problem, the massive churning of the consumers, poor dispute resolution mechanism. So, these are some problems which are with the distribution sector. The end user of the electricity, like household, farmer, commercial establishments and industries, confront many problems. What are these? These are like frequent power cuts. These cuts can be scheduled. At particular time the power cut is there, but and it can also be the unscheduled. So, this is a problem. The faulty metering and inflated billing, erratic voltage and the poor quality of the power have further added to the power woes in of the customer. The further, people in large number of the villages and the small town have limited or no access to electricity. Learners, have you asked yourself, where does the problem lie? What areas require to be improved? How can we bring about a change for the better? So, we shall address these and other such questions in our coming sessions. So, learners, in this session we have presented a bird's eye view of the electricity sector in India with a special focus on the main problems that we are faced in transmission and distribution system. With this, I am closing this session. So, best wishes and happy learning. Thank you.